Okay, I'm back, and so now we want to talk about where do you find earthquakes. Now, most earthquakes are going to occur at plate boundaries. So let's go back to plate tectonics and try to remember the different ways that plates interact. So plates can diverge, meaning they're going to be pulled apart. Plates can be transformed, so they slide past each other. And then plates can converge, and then you also had intra-plate activity, so activity that was going on within a particular plate. So all of these are different places where you can have earthquakes. So let's talk about the differences between them. All right, so let's first talk about divergent plates. So at a divergent plate, you're going to have two plates that are going to be moving away from each other. So let's say it's like this. All right, now one way of having an earthquake would be as the magma is making its way up to the surface, it's going to be getting into the cracks of pre-existing rocks and breaking them open. So that could generate earthquakes. Another way that it could happen is that as these plates are sliding apart, what's going to happen is that you're going to have faulting occur, and it's going to be down faulting. So like, for example, this plate right here is going to slide down kind of like that. And then this plate over here is going to slide down kind of like that. So what you're going to end up with is a series of faults that look kind of like this. And then over here on the other side, you're going to have something very similar to it. So as these blocks of lithosphere are sliding down due to tension, as these plates are being pulled apart, that's going to generate earthquakes. You can also have the same thing on continents. So like, for example, we said that the continent of Africa is being pulled apart due to divergence. So again, you could have earthquakes as a result of the magma coming up and getting into rocks and breaking them apart. You can have also magma as it's being emplaced into the lithosphere. You could also have it as this down faulting starts to occur as the plates are being pulled apart. So all of those are different ways of generating earthquakes. Okay, now normally the earthquakes that are generated from divergent plate boundaries are not that severe. Okay. On the other hand, let's look at a transform plate boundary. So with the transform plate boundary, you've got two plates, they're getting stuck together, and then all of a sudden they slip, and then that's going to generate an earthquake. So an example of this is the San Andreas Fault in California. And so this can generate significant earthquakes because there's a lot of force that's pushing those two plates together, and then also a lot of force that's trying to get those two plates to slide past each other. And then when they finally do break, that's going to release a tremendous amount of energy. So at transform plate boundaries, you can have significant earthquakes. Okay, what about at a convergent plate boundary? So if you recall, there were three different ways that plates could converge. So that you could have an ocean that is going to collide with an ocean, and then one of them's going to go down, but whichever one is the cooler of the two plates, it's going to go underneath it, and then part of it's going to melt, and then it's going to go back up to the surface, and then you're going to have your volcanic islands as a result of it. So there's going to be significant stress and strain that's going to be developing as one of the plates that's going to catch underneath the other plate, and then it will finally dive underneath it, and when that happens, then this plate is going to snap, and when that happens, then that's going to generate a lot of earthquakes. So if you recall, there was a terrific tsunami, a big tidal wave that hit the coast of India a few years ago. And that was a result of a subduction zone in Indonesia, where you had one plate that was going underneath another plate in Indonesia, and it produced this earthquake when it finally did slip. Also, the earthquake that they had in Japan, same thing. So Japan is a subduction zone where you've got one oceanic plate going underneath another oceanic plate. So subduction zones are going to cause a lot of earthquakes to occur. Okay, the next kind is going to be a continental ocean collision. And so this time you're going to have a continent, and then the ocean is going to be diving underneath it. So again, you've got a big subduction zone occurring there. A prime example of this is going to be the Andes Mountains in South America. And so they have some of the most terrific earthquakes whenever one plate gets stuck as it's going underneath the continental plate, and then when it finally does slip, it lets loose with a big earthquake. And then you could also have a continental. So this time when the two plates collide, they're both very buoyant, and so they tend to crumple upwards. And so this time you're going to get the tallest mountains in the world, so like the Himalayas, are going to be a result of a continental collision. And so again, that can also give off earthquakes. So in the news, we hear there was a very bad earthquake that happened in the Himalayas, and it flattened the city of Kathmandu. And then there was also in the news, there's earthquakes that have occurred in Turkey, for example, where one plate is grinding into another plate. Okay, so then the fourth example is going to be intra-plate earthquakes. And so an example of this might be at Yellowstone National Park, where you have the North American continent, and then there is a hot spot underneath it that is sending up material, and so that heat from that hot spot is what drives all the geysers there in Yellowstone National Park. Well, as this magma comes up, though, it can break apart rocks and generate earthquakes. So this is one of the ways that we might be able to forecast an earthquake, is by the miniature earthquakes that are going to be given off just prior to an eruption. All right, so how do we then, now that we know how big an earthquake is, how can we quantify the amount of damage that this particular kind of earthquake can do? So we'll talk about that in our next segment.